All of you, welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in the light topic we have completed so many sessions. Okay, still one session is pending, that is, you know very well, lenses. Okay, refraction through the lenses. So we need to discuss the topic, and we are going to end the very big topic, light. Okay, so let me start the session, guys. So all the mirror parts we have completed, and refraction of light, and that examples also completed. Mirror formula, plane mirrors and their formulas. Okay, and I have completed MCQ session of light also. You can just click on the playlist and you can find out. So interference, diffraction. So all the topics completed now. So only the lens topic is pending. So now we are going to discuss that lens topic. Okay, so here whenever we are going to start this topic lens, we need to compare with the mirrors. Why? Because we are already very well about the mirrors now. So by comparison with the mirrors, we can get the idea about lenses. Okay, are you getting my point? So here I want to give one important, that in the mirror what we are observing. So if you send some light to the mirror, in most of the cases it will be reflected back. So mirror is a reflection phenomena. In the same way, if you can consider lens formula, if you can consider the lens, what is happening here? If it is any lens, if you send some light through the lens, it will be refracted. If it is a normal, it will be bent away to the normal, or towards to the normal, if you can consider is the normal. So it may be refracted. So here you will get refraction concept. Okay, so mirror, if you send some light, it will be reflected back. If you send some light through the lenses, it will go through the lens. That means you can say lens is a transparent medium, correct? So that's why whatever the light flowing that through the lens, it will be go through that one. So it is a transparent medium. Okay, and these lenses are made with the glass called as flint glass. That is nothing but one type of pure glass. So whatever the light flowing coming to the lens, it will be flow through that lens. Okay, so all of you getting the difference? In the mirrors we have two types. What are those? We have concave and convex. Here also same. The lenses also we have the same phenomena. Concave lens, convex lens. Okay, so we have already discussed about the mirror. Concave mirror is also called as, concave mirror is the converging mirror. Okay, and opposite of this, what is the opposite of concave mirror? Convex mirror. What it will do? It diverges. So that means diverging mirror. We know very well about this, correct? So here in the mirror it is a reflection, in the lens it is a refraction. That means you can say mirror and lenses are almost opposite. So if you know this one, we have the concept of lens. Okay, if we know this one, that is enough. So we can understand easily about the lenses. Okay, so here concave mirror converging and convex mirror diverging. So opposite of this, in case of lenses it is opposite now. So it is opposite means It is opposite means here concave lens. Okay, here concave mirror converges means concave lens opposite na, opposite of this one, in the sense it will be diverges. Diverges. So diverging lens. Okay, opposite of this. So concave lens opposite convex lens. So convex mirror, diverging mirror means convex lens, converging lens. All of you got it? So here I am using just opposite principle. Okay, it is not a principle, it is a trick to remember, trick to get the idea. Getting my point? Okay. So in the mirror, we know very well, concave mirror is a converges the light, convex mirror diverges the light. So opposite of this, okay, concave mirror place, here concave lens, converging plus diverging, opposite. Okay, here convex mirror diverges and convex lens converging. So we can finally make a important note. So which are converges and which are diverges? Concave mirror and opposite of this. Opposite of this. What is the opposite of this in the lenses? Convex lens. Both are converges. Converges light. Okay, in the same way, opposite of this. Convex mirror and opposite. Concave lens. All are opposite only. Diverges the light. Diverges the light. Okay, so all of you clear? Concave mirror, convex lens, converges, convex mirror, concave lens, diverges. Okay, so here if you are not get anything about this, no need of worry, guys. So you have previous session about the mirrors. Whenever you are in free time, okay, whenever your mind is ready to accept anything, okay, then only try to watch the light session. Okay, otherwise don't start light. Why? Because it is very understandable concept. Once you got understand, it is very easy topic. You never forget. Okay, and here also giving some tricks to remember opposite principles. Okay, and we know very well in the previous session I have already given what is converging and what is diverging. As the name itself converges in the sense compress. So light rays meet at any one point. Light rays meet at any one point, that is you can say converges. In the same way diverges, divide. As the name itself, diverges means divide. So divide in the sense from one point it will be divided. So just you remember this point. When only your mind is ready to accept this converges and diverges topic. Okay. Otherwise, your mind feel that those are foreign words and your mind may not ready to accept. So first of all, you have to train your mind. Okay. These are nothing but converges means compress, diverges means divide. Okay. So now coming to the lenses. Here in the lens also we have the two types of the lenses, same concave and convex. Okay, so first of all we need to write the lens definition. After that we will discuss both type. Okay, so lens is a transparent material. A transparent material or medium bounded by two surfaces, and of which one or both surfaces are spherical. Both surfaces are spherical. These lenses are two types. Okay, how the lenses are formed? Now I am giving. So if we have the spherical parts, okay, it is very big. I want to take very small. Okay, I am going to take two spherical. This is the one spherical. Here we have the center of this one, and one more spherical is like this. Okay, now it is also having center. So here this combined part, the combination part, what is this combination part? This part, that means this part is nothing but, say, it will be act like a convex lens. Okay, so you need to remember this one with a small trick. You know our human eye. This is our human eye. So I'm giving the tricks are here. So this is like our human eye. Remember one thing, our human eye is act like a convex lens. If you remember that one, our human eye is convex lens. So just rotate this one. If you rotate or in vertical, you are getting like this. So it is the convex lens. So if you know that one, you can get idea about the concave lens. Okay, in the concave lens, what is happening in the sense? Okay, here the two spheres are not touching each other. You have some gap. Okay, and that combination, this part. Okay, this part means here you have in the first sphere, you have this part. I am taking here in the second sphere. I am taking this part. Okay, so this is the concave lens. Okay, so if you can consider here at the end, this is one end, this is the another end. So ends are thin, correct? Ends are thin. At center we have thick, correct? Here at center we have thin. At the end we have thick, correct? So we can define the convex lens. Here thicker at center, thinner at the ends. Okay, so how to remember this? This convex lens is same like our human eye, just to rotate it or vertical it. Okay, then you will get the convex lens. So convex lens, at the ends we have thin, at the center we have a thick. All of you clear? So you will get a very important question. So thicker at center, thinner at ends, that is which type of lens? That is convex lens. In the case of concave lens, we have thicker at ends, thinner at center. Okay, and we know very well this convex lens is converging, concave lens is diverging. Okay, is diverging. I think all of you clear about this? Yes. And after this, we need to discuss lens formula. Lens formula. I have already given the mirror formula. So if it is a mirror formula or lens formula, what is the first important rule? All the terms are in the reciprocal. 1 by V, 1 by U, 1 by F only. Okay, if it is a mirror, we have the addition. 1 by V plus 1 by U is equal to 1 by F. If it is a lens less minus. Lens less minus, so minus you have 1 by V minus 1 by U is equal to 1 by F. You know very well about the U and V and F. Okay, so same like in the mirror formula. V is the U is the object distance, V is image distance, F is focal length. Okay, now we are going to discuss some important terms in the lens. So we have already discussed the important terms in the mirrors na. So here lenses also almost same. Lenses also almost same. So I am going to take the two lenses. Okay. So our human eye is convex lens. Okay. I am very weak in diagrams. It is by drawing with the pen tab, it is somewhat of difficult. Okay, yes. So it is the concave lens. So in the same manner here, we have one center of the lens, that is nothing but optical center O. Optical center O. Optical center, that is you can say O. The axis which is flowing or which is moving through the optical center is nothing but principal axis, same like a mirror. Okay, so if you can consider this part, this half of the part, this half of the part, it is like same like a mirror na. Arey yaar, it is not in a spherical shape. Try to adjust kar. Okay, so here yes. Okay, so in this case here we have the center and focus and all those na. If for this mirror also it will be, if it is like this. Okay, so here also we have the center and focus and all those. So I'm going to take all those points here. Okay, so for this red color, this stripe, okay, this red color side, here we may have the focus. Okay, here if we may have the center of curvature. So center of curvature in the lenses, just to take it as 2f. Take it as 2f. 2f is nothing but 2 times of the focus. Okay, here for this mirror, this color, I want to take green, this color. For this one, here we have the focus, and here we have the center of curvature. So let us take that is a 2f. That means you can say here in the lenses we may have the two focus points. two focus points. We may take as f1 and f2. Okay. In the same way here, in case of this concave lens, here also we may have focus and center of curvature 2f for this spherical part. Here we may have the center of curvature, here we may have the focus. So focus, center of curvature I am taking as 2f. Okay. So in the lenses, they have not given the point center of curvature. Why? Because here we have already one optical center is there. So to avoid the confusion, instead of center of curvature of the sphere, they will give as 2f. They will give as the 2f. Okay. So here it is a focus and it is the 2 times of the focus. All of you clear the points? Okay, clear the points. Here in case of mirror, we know the focal length. Focal length is nothing but from focus to pole. So here in the place of pole, here we have the optical center now. So from optical center to focus, we have the focal length. We have the focal length. Okay, F. We have the focal length here from optical center to focal length. We have the F. Okay, so note down the points, then you will get idea about all this terminology. Okay. We know the principal axis. No need to take about the principal axis. Mainly focal length is required. Focal length. This focal length is nothing but distance between focus and optical center. Optical center, that is OF. Okay. And what is the optical center? What is the optical center? This is the center. This is the point. Is a point within or outside the lens directed to which incident rays can pass through without any deviation. Any deviation in the path. Without any deviation in the path. So that is nothing but whenever any light ray passes through a point, then it may not deviate. So it may have the same path. Okay, it may have the same path. So here also. It may have the same path. Then that point is nothing but you can say optical center. Okay. Simply you can say center of this convex and center of this concave. Center of this concave. Okay. All of you clear up to this? Yes. Now we are going to discuss the very important thing is image formation by lens. Image formation by lens. Just wait. I think the slides are completed. Okay. So image formation. Here I want to give some important points only. So I don't want to discuss in detail. Why? Because we have already discussed a lot in the mirror. Same opposite here. Okay. Image formation of lens. So just to use the opposite concept. The trick is opposite concept of mirror. Opposite concept of mirror. Okay, so in mirror, what are the possibilities we have? Concave and convex. Okay, so in case of convex, we may have real images and virtual images. Both are possible, correct? In convex, we have only virtual. We know very well all real are inverted. This is the same concept in both mirror or lenses. All virtual will be erect. So I have given what is the real, virtual, and all those. Okay. Okay. So in case of lenses, it is just opposite. Just opposite. Convex we have to take, or take concave if you want. Just opposite I am taking. Concave and convex. So here just opposite means whatever the convex phenomenon or convex concept will be same like concave. Both are opposite na. So that means here in case of concave lens, opposite means here opposite of real, here only virtual possible. In case of convex lens opposite of that is same like opposite of convex mirror here. So that means same like concave. So here real possible, virtual possible. Okay, real possible, virtual possible. So make small trick here. So the concept of concave mirror is same like convex lens. Okay, so opposite principle na, opposite are same, in the same way convex mirror concepts are similar to concave lens concept. Okay, so if you know that one, you can easily get the idea. And here in case of concave, you may get the phenomena that is enlarged, or that is magnified images, comma, there is a chance of same size and also the chance of diminished, correct? Diminished. And here the convex only reduced images, diminished images, reduced size only. So here concave lens is same phenomena of convex mirror. So that means here only the chance of reduced images, reduced size. Convex lens same phenomena of concave mirror, that is all the three are possible. Okay, magnified, same size, reduced. Okay, so if we know this, we can give the answer for any of the questions. Okay, already you know very well about the mirror. Just compare, just opposite principle of the lenses you will get. Okay, now I am going to give the important table. Okay, but here in the lenses we don't have center of curvature. Instead of center of curvature, here we have the 2f. Okay, the first one, position of object. Okay, and position of image, size of image, nature. And if you want, diagram. Okay. So first of all, I'm going to take a convex lens. Why? Because convex lens having so many cases. Okay. So here I am going to take this one as for convex lens. Okay. Convex lens. We have the optical center. Okay. Optical center. Here I have the focus 1. I'm going to take focus 2. Okay, first of all, position of the object I am taking at infinity. First case is infinity only na. So if I am going to take, the object is at infinity. The object is at infinity. So whenever any one parallel ray strikes the lens, what will happen? It will go through the focus of the other side. So here let us take f2 and 2f2. Okay, so it will this convex lens is nothing but which nature? Convex lens, converging nature. That means compresses. Compressor means it will be go through the focus line. If you take one more ray, then it will also go through the focus. Okay, if you take one more ray, okay, one more ray, and it will also go through the focus. Okay, here refracted in case of mirror's reflection. So we know very well what is the position of image wherever the reflected rays in mirrors. Here refracted rays in mirror. Okay, the point wherever the refracted rays meet. So this is the image position. So image position is nothing but you will get at focus 2 and it is a point size. Point size. We know very well the size is nothing but from principal axis. Okay, distance from the principal axis. This is the principal axis now. So distance from the principal axis, it is just as a point shape. So point size means extremely diminished. Extremely diminished. Okay, and what we learn about the convex lens? Convex lens always real and all real will be inverted. So real and inverted. Real and inverted. Okay, so that means when we will get the real? Here whenever the image is formed in the refraction case. Image formed in the refraction case, that is lenses lenses basic phenomena is nothing but refraction. If it is refracted, that is the real. That is the real. If the image formed here, that means in the same, then that will be a virtual. Okay, that will be a virtual. What is the real case? In the mirror real case, mirror is nothing but reflection. So if it is formed in the same axis, then we can say that is real. If it is following real phenomena, that is the real. Here it is following real phenomena, refracted only, na, refracted through the lens. So that is the real. So all real will be inverted. Okay, so that is somewhat of opposite. Okay, opposite to that of mirror. Second case, we can move our object. We can move our object from infinity to beyond 2f1. Correct. So at beyond 2f1. In the mirrors we have taken beyond C, beyond center of curvature. Here beyond 2f1. So I am going to draw the diagram. Optical center, principal axis. Okay, so here we have the f1 to f1. Here f2 to f2. So I am moving. Here it is the infinity. Here I am placing here A, B. Okay. So here also I am taking any one parallel ray that strikes the mirror. Sorry, here we have to take a little bit change. Generally, those will be reflected or refracted from that optical center. Okay. So little bit change in the diagram. From this point, it will be refracted. It will be refracted. Okay. So here also I am going to take any parallel ray strikes the lens. Okay. After that, it will be refracted. Okay. So it will be refracted through the focus. Correct. Same like previous. And one more thing, if it going to be the parallel ray is in with some angle like this, or with it is flowing through the focus one, flowing through the focus one. So if it is flow through the focus, after refraction it will be parallel, na? Just opposite. If it is a parallel ray, it will go through the focus. If it is go through the focus, it will be parallel to the principal axis. So parallel to the principal axis is nothing but like this. So the two refracted rays meet this point. This is the image. Okay, so here also real, all real will be inverted. And what is the size? Here this much of size, here this much of size. So that means reduced in size. Reduced size. That means you can say small size. And the formation beyond F2, between the F2 and 2F2, na? Between F2 and 2F2. So this is the F2, this is the 2F2. Okay, now coming to the third one. Third one, we can move from this point to this point at 2F1. So that is same like center of curvature at 2F1. So if, that means in bracket you can make it as center of curvature. At center of curvature, what is the concept you got? Same size, na? Same size of the image we got. Okay, and the place, same place, that is 2F2. It will form 2F2. So here this is the same, real inverted. This is the key point, same like in the mirror. Okay, same like in the mirror. So note down this one also. F1 to F1. So I am placing at 2F1. F2 to F2. Okay. So here it is a part of two mirrors now. So that's why two focuses we have. So here also same. If any one parallel ray strikes the lens, it will be refracted through the focus. Through the focus. Okay. And if any one light ray flow through the focus, after reflection, it will be parallel to the principal. So this is the refraction rays are made. So this is our image point. So that is at 2F2. Okay, and we have almost same size. Almost same size. Okay, in the same way, if you go to remaining, same like between F1, and after that you can move to F1 to F1. So between 2F1 and F1. Okay, then you will get beyond, same like in the mirrors, beyond, okay, beyond 2F2. That means whenever you coming near to the lens, the image formation is going farther. The image formation is going to be farther. Same concept like a mirror. So in the mirror also, whenever the object is coming near to the mirror, image going to be farther from the mirror. So here also, whenever whenever object is coming near to the lens, here note down. Whenever object coming near to lens, image formation is farther from lens and size increasing. So from same size to increases to magnified. So real and inverted. So I'm not drawing the diagram again. Okay, so I will give the table in the PDF. Okay. Now coming to the next one. What is the next chance? Between 2F1 and F1 also completed. Now at exactly F1. At F1. So at F1 means from after this F2 there is a chance of infinity only. So there is a chance of infinity only. So at infinity, object position, image position, size of image and nature of image. Nature of image. Okay. So at infinity. So at infinity means extremely magnified, very bigger image. Okay, real and inverted. Okay, if we move before, that means between F1 and lens, between F1 and lens, at between F1 and lens, very near. If you place same like in the mirror, what will happen? The image formation will be in the virtual. So here also same virtual. All virtual will be erect. Okay, all virtual will be erect, and we will get some magnified size now. So here magnified size. So it will be on same side of lens. Okay, that is reflect. It is same like reflecting type. Okay, so on the same side of the lens. So these are the formations in case of convex lens. Same you can consider concave lens. Okay, here we have the 2 points only, 2 chances only. Why? Because in case of convex lens also we have the 2 choices. So here if you place at infinity, you will get that is on same side, on same side of lens, and especially at a focus point, at a focus. So here we will get point size, so highly diminished. So point size, whenever in case of mirror, lens, or concave, convex, whatever it may be, at infinity means at a focus only, and the size is point size, that is common for anything. Okay, any type of question. And here in case of convex lens, only the chances of virtual and erect. Virtual and erect, blindly we can give. And the second chances we have at a finite distance, or in between infinity and the lens, at a finite distance, or between infinity and lens. Okay, here same like mirror, here what you will get, between focus and optical center. In that mirror we have between focus and center of curvature na, so here between focus and optical center on same side, same side. Okay, here only the chance reduced or diminished, reduced. Okay, so virtual and error. So what may be our applications, we can say? Convex lens, these are converges, converging lens. Converging lens in the sense compress, compress, that is at one point all will be compressed. So that means we can have the focus, so wherever the focus is required. Okay, so whenever there is, we can focus on a particular point. So whenever focus required, you can go with convex lens, same like a concave mirror, correct? Both are same, opposite. So whenever focus required, we can use convex lens. Convex lens in case of lenses. In case of mirrors, in case of mirrors, concave mirror is used. Clear? Okay, in the same way, convex lens, there is a chance of magnification. So a magnified, extremely magnified, okay, magnified. So magnification is done by convex lens. Okay, these are diverging, diverging in the lens, in the sense from one point it will be divided. So that is diverges. So that means wherever we require magnified, magnified images, that is bigger images, bigger images. So in magnified images or bigger images, we will get. So whenever bigger images required, we go with a convex lens or concave mirror. Okay, for example, microscope. Microscope. So in microscope we require magnified images. Telescope. Telescope. In that telescope also we require magnified images. So in all those cases we go with the convex lens. And in our human spectacles also, in our human specs, in the specs also we require some magnified images. So in that also we go with the convex lens. Okay, so all of you clear the applications? Application. Okay, and after that one more thing is there, linear magnification. Linear magnification. We can we have already discussed about this linear magnification in the mirror. So same here, m is equal to, we know very well, image size by object size. Image size by object size. Okay, image size by object size. And after this we need to discuss one more thing, power of lens. Power of lens. What are the units of power of lens? Units are diopter. Units are diopter. D. Okay, units are diopter D. So the power of lens is nothing but inversely proportional to focal length. Power is nothing but 1 by focal length. Okay, so this is a very important question. In so many cases they will ask about this formula. They will give the focal length and asking the power. Okay, it is the reciprocal of the focal length. And here one important question also there. The power of convex lens and concave lens. Power of convex lens is positive or negative? So many students will have the confusion. I want to give a small thing. Okay, I want to give a small thing. Due to the convex lens, we are getting the bigger images. So bigger images means big means positive. So positive in the sense positive. Or use another trick. What is another trick? X is there now. Just rotate this X. If you rotate the X, then you will get a plus. So simply remember like that. So power of convex lens is the positive. And if it is a positive, no need to remember another one. Na? Concave lens, negative. Concave lens is negative. Okay. For example, if the doctor prescribed as plus 2.0D lens, then plus in the sense he has given convex lens. Okay, convex lens. If you want to focus, that is 1 by power, that is equal to 1 by 2, that is equal to 0.5. Okay, that is equal to 0.5. Okay, if the doctor has prescribed minus 2.D means minus for concave, minus for concave. Okay, minus for concave. I think we may not complete this light syllabus in this session. Still, we have some more topics. What is the critical angle and total internal reflection? Uh, I don't want to take another session. I want to complete here only, but I want to give in a brief only. Okay, so not in a full manner. Okay. So what are the topics are pending? Critical angle. Critical angle and total internal reflection. Total internal reflection. You can simply call this one as total internal reflection, TIF or TIR. TIR. Generally, we denote this one as TIR. So this total internal reflection concept is nothing but it is used in the optical fibers. Okay, nowadays we are using the data, that is that is internet through the modem. Okay, so how the data is transmitted? Is transmitted just like the concept of total internal reflection. Okay, so whatever we are talking, whatever we are browsing, that voice or data will be converted into light. Okay, that light will be transmitted through the optical fibers. And other end, that light is again converted into voice and data. Okay, in that way the transmission of voice and data nowadays is transmitted. Okay, so in previous days we are using the copper cables, but that is a very high cost and so many disadvantages are there due to the resistance of the copper. Here in the concept of optical fiber we don't have any loss. Okay, a very little bit loss, that is due to joint of the fibers. Joint of the fibers is called as splicing of fibers. Okay, we don't need that much of thing, just a concept is important. To remember the concept we require some additional data. Okay, so total internal reflection concept is mainly used in first one, optical fiber, optical fiber working principle. Second one, mirage formed is due to that is total internal reflection. What is this mirage? That is optical illusion. Optical illusion. That means in case of deserts, okay. So in case of deserts, there is no water, but whenever we see from longer distances, that is the shadow is looks like a water, okay, look like a water. That means it makes optical illusion. And the third one, shining of diamond. So the reason behind the shining of a diamond is nothing but total internal reflection. Okay, so in the rainbow main causes is main cause due to dispersion and also a little bit of total internal reflection. Okay, so now we are going to discuss what is this critical angle and what is this total internal reflection in a brief manner. Critical angle is denoted by the letter C. So it is the angle at which the light ray will be refracted to reflection mode. Here the angle at which the light ray will go refracted to reflection mode. Okay, so the light ray at which the angle at which the light ray will go from refracted mode to reflected mode is nothing but you can say critical angle. Okay, so here if we can consider about this critical angle, if it is the incident ray, here the angle of refraction is 90 degrees. If the angle of refraction is 90 degrees, then that is not that particular angle is nothing but critical angle. That particular angle is nothing but can say critical angle. Okay, so just I am giving some data, then you will get understand about the critical angle and all those. Okay, so note down the point about the critical angle. The angle of incidence in denser medium, take it is a denser medium for which the angle of refraction, this one, the angle of refraction in rarer medium is the rarer medium becomes 90 degrees, then you can say that angle is nothing but critical angle. That angle is nothing but critical angle. A very simple thing, guys. Whenever light rays passes from denser medium to rarer media, if that angle is approximately 90 degrees, that is, if you send like this, it is 90 degrees to this one, 90 degrees to this one. That means this is the 90 degrees. Okay, so this angle is nothing but you can say critical angle. So in this critical angle, what is happening? Angle at which the light ray will go refracted to reflection mode. So that means refracted to reflection mode means actually it is the refraction denser to rarer. If it is moving denser to rarer, it is a refraction. But instead of refraction, it will go, if it is angle is greater than 90 degrees, if the angle is greater than 90 degrees, 90 degrees, it will enter into reflection mode. Reflection mode means again it will enter into the denser mode, denser medium. Again it will be enter into the denser medium. That is nothing but you can say total internal reflection. That is nothing but you can say total internal reflection. Reflection. Okay, the angle is more than critical angle. It will be reflected back. Reflected back means reflected to denser medium. That is nothing but total internal reflection. All of you getting? So what is the critical angle? The angle at which the light ray will go from refracted medium to reflection medium, or refracted mode to reflection mode, or the angle at which it will move from denser medium to rarer medium. Okay, so the angle of refraction is 90 degrees. The angle of refraction is 90 degrees. Then we can say that is a critical angle. Okay, so the next one, total internal reflection. TIR, total internal reflection. Okay, so whenever we remember in a short term, that is TIR, like that, then our mind feel that we know that one very well. So that's why you remember a short term. Okay, that is a advantage. So whenever our mind accept, it is ready to accept the concept. Okay, now I am giving a small thing about this. Here I am going to take it is a denser medium. Okay, so it is the rarer medium. I am sending light from denser medium to rarer medium. Actually, it is going to be refracted. Correct? It is going to be refracted, maybe bend like this or like this, maybe bend. Okay. So generally, what you can say, denser medium to rarer medium, it is away to the normal. If you can consider, it is normal, it is bent away to the normal. That means it is going to be bent like this. But what is happening? If you are sending this angle is nothing but whenever the theta is greater than critical angle. Okay. So that means if you are going to take another ray. Okay. If you can consider this angle theta 1 is greater than the critical angle, then what will happen? It will be reflected back in the same medium. So it will be reflected back in the same medium like this. Okay, like this. After that, what will happen? If you have again here, this will also, for example, this is another rarer medium. Okay, now denser medium to rarer medium, if the angle is greater than the critical angle, what will happen? Again, it will be reflected back to the same denser medium. So again, moving. Again, it is flowing. So that means here, internally, if it is a optical cable, optical fiber. Okay, so if you send the light ray that is greater than the critical angle, so the angle of incidence is greater than the critical angle, it will be internally reflected. So in this way, the light is going to be moved. So the light will be travel in the optical fiber based on total internal reflection concept. Here, no absorption of light takes place. No absorption, that means no loss taking place. So in this way we can transfer the voice or data into the optical fiber for a longer distances. Okay, without the optical fiber we cannot expect the data this much of speed. Okay, in the copper cable maximum we may get up to 10 Mbps speed. Okay, so not more than that. In the case of optical fiber, we can get Gbps also because there is no loss. Okay, so note down the point here. The condition The conditions for total internal reflection. We have two conditions. First one, light has to travel from denser medium to rarer medium. So we know very well what is the denser. Denser medium means denser is nothing but dense means less. Okay, so the speed of light is less, in which the speed of light is less. Rarer medium means in which the rare is more. Rare more. I have already given this in the previous session, so try to watch that one. Speed of light is more. Okay, travel from denser medium to rarer medium. So that means a low speed to high speed, denser medium to rarer medium, and the angle of incidence. Second one, angle of incidence theta must be greater than critical angle. Critical angle. Then only the light will be in reflection mode. Okay, so the light is propagated propagated from denser medium to rarer medium, and angle of incidence is greater than critical angle critical angle. But then what will happen? Then the light is reflected back. Light is reflected back to denser medium. Reflected back to denser medium. Okay, reflected back to denser medium. This is called total internal reflection. Okay, here in total internal reflection, no absorption takes place. That is, no loss takes place. Okay, no loss takes place. So examples are applications: optical fiber works on total internal reflection. Okay, and second one, mirage. This is nothing but you can say optical illusion. Okay, so in the desert, if there is no water, is also looks like a water is there. There is a pond is there, but whenever we enter near to that one, there is no water. So that is a optical illusion. That is a mirage. That is due to dry air and difference in the atmospheric layer. Whenever the atmospheric layers are different, so in some case, in some layer there is a moisture, some layer there is no moisture. So that means due to that the mediums are different. So the mediums are different. One will be act as a denser, one will be act as a rarer. So due to that, we may get the optical illusion. Okay, and sparkling of diamond or shining of diamond. Okay, and also looming also the concept of total internal reflection. Okay, and shining of bubble in water. Okay, so here also we have the concept of total internal reflection. So shining of air bubble, not only total reflection, there is also, you can say, interference of light also. Okay, so to avoid the confusion, I am going to eliminate this. Both are there. Okay, so these are the three important uh, examples of total internal reflection. Okay, students, I think the topic of light is completed. Okay, so with your help only, I have completed this large topic. Okay, and also try to practice the MCQs. Try to practice the MCQs. In the MCQs playlist, I have completed the light MCQs with the problems in mirrors and lenses. Okay, so try to watch that one. Okay, students, if you really like my effort, don't forget to click on the like option. Okay, thank you so much, guys.